This is lesson 1 of unit 3, which is still based on quadratics, so we're just calling it quadratics part 2. So this first note should be mostly review, and like you can see, or as you can see, I have already kind of filled in this note with this red writing. So just because there's a lot going on here, I'm going to be writing less. So your note, you will have to fill in, I think, everything that's in red here. So we're just going to start talking about expanding binomials. So before we kind of get into it, we're going to define a couple of terms. So the first is polynomial. So a polynomial is an algebraic expression made up of terms that are added and subtracted. So we've been dealing with polynomials all throughout this unit. It's just basically multiple terms that, again, are either added or subtracted. A term is the product of a numerical coefficient and one or more variables. So again, don't get too caught up in these definitions. They are just there to help you. It's not like you necessarily need to memorize either of these first two, and the last three are pretty straightforward. So a term is just a product, which means after you multiply two things together, you get a product. So that would be multiplying the coefficient. So that's another definition that you might not remember. The coefficient is the number out front of the variable. Okay, so it's the product of those coefficients. A monomial, okay, that one starts with mon or mono, and mono we know means one. So that is just simply a polynomial that has only one term. Okay, a binomial, again, we have that out front. We have bi means two, so that is a polynomial with two terms. And lastly, we have a trinomial. Again, that should be somewhat familiar to you, that tri means three. Think about tricycle. That is a polynomial with three terms. Okay, so moving on. And again, you might, just because I'm not writing, I'm probably going to go through things a bit faster, so you might have to pause the video to copy those out. Okay, so let's quickly review expanding. So expanding is the process of multiplying terms together and collecting like terms to simplify. Okay, so again, a couple things you need to know here. Like terms, remember, and we did go through this in the review, so it should be somewhat fresh, but like terms are terms that have the same variable and the same exponent. Okay, so x squared and x squared would be like terms. 5x squared and negative 7x squared would be like terms. Okay, 5x and 3y are not like terms because they don't have the same variable. Okay, the distributive property, all that means is that you're multiplying the terms. So we can see here in this example. So if we had a times b plus c, if we were distributing, what we're doing is we're taking whatever is out front. So we're taking that monomial out front and multiplying it into our binomial. So we're doing a times b, which gives us this product ab, and a times c, which gives us the product ac. Okay, and don't get confused just because those are variables. It would work the same way if they were numbers. Okay, so let's look at a couple more kind of in-depth examples here. So it's asking us to simplify the following. So the first one we have is 12x plus 3y minus 13x plus 5y. So the first thing we're going to want to do is we will put the like terms together. Okay, so that means putting those terms that have the same variable and the same exponent together. So we have those two terms that I just underlined are both x's, and these two terms are both y's. So you will see underneath where I just underlined that we just simply move them together. What's important here is to keep the sign out front attached, right? So 12x was out front, so that was fine. We knew that was positive. So 12x minus 13x, right? And that's because that minus out front is attached to that 13x. Plus 3y plus 5y. Okay? The next thing we need to do is simply add or subtract those coefficients. So in this, and remember the coefficient is the number out front of the variable. So my coefficient of 12x is 12. My coefficient of 3y is 3. Okay, so here I'm just doing 12 minus 13 gives me negative 1x. Okay, and then for the y's, I have 3 plus 5 gives me 8y. Okay, so that's an example of just collecting your like terms. So the second half of this process up here that I just kind of scribbled under. Okay, so this next term, or this next example rather, involves both the expanding element of it and the simplifying element. So we are going to have to use that distributive property. Okay, so for this one we have in brackets 2x plus 4y minus 5x minus 6y. Okay, because those are in brackets, it's that whole thing minus that whole thing. So the first binomial minus the second binomial. Remember, there's two terms, so that makes it a binomial. So the first thing we need to do is distribute that negative. So anytime we see a negative sign, and I mentioned this before, we need to imagine that there's a 1 there, because for some reason in math we don't always put that 1. Okay, so that is actually negative 1, as you can see on that next line here, right? So what we first need to do is we need to distribute that negative 1 into our bracket in just the same way that it tells us how to do it up here. Okay, so you're taking whatever's out front and you're multiplying it by each thing in the bracket. So here we have negative 1 times 5x. Okay, so we're just dealing with the coefficient. So negative 1 times 5 is negative 5, and you carry the x. Okay, negative 1 times negative 6 is positive 6, and you carry the y. Okay, so we've done the distributive property. Now we need to remove our brackets. The reason we can just remove the brackets from this first binomial is because there's nothing out front to distribute to it, right? If I had, like, say this 2 wasn't the question number and it was actually a value out front, then before I dropped the brackets, I would have to do that distributive property. Okay, but there's nothing out front, so I can just simply drop those brackets. Once I've done that, all I have to do is collect my like terms, okay? Because, again, I can't do 3x plus 4y. I can only put x's together and y's together. So I have 3x minus 5x gives me negative 2x, and 4y plus 6y gives me that 10y. Okay, so that was our review of expanding and simplifying and collecting like terms. Now let's move on to multiplying binomials. Okay, so when we're multiplying binomials, remember that means there's two terms in both. Okay, so we are going to use what we call the distributive property. And again, like I said, this should really all be review. Okay, so the distributive property, a way for us to remember how to use it, and I'm sure you've heard this before, is that term FOIL. Okay, so FOIL stands for first, outside, inside, last. And what it's telling us is the order we should be multiplying our binomials together. Okay, and you can see there's a very nice visual here, where it shows you each of those steps, right? So this arrow, this first arrow that has an F on it is what you should be doing first. So A times C gives you that product AC. Next is O. A times D. Oh, does it not do it in order? Outside. This isn't in order over here, I guess. Unless that should just be a D. That's possible. Okay, so A times D is obviously AD. Inside is B times C, which is that BC. And lastly, we have B times D. Yeah, so that's just an error. Make sure you correct that on your page. That should say AD. Okay, so that is how we use FOIL. Obviously, again, that is with the variables, so don't let it confuse you. It's going to be the same thing if we have actual numbers. So let's look at some examples here. So this first example, so we have x plus 2 times x plus 4. So again, I always, like I told you in the review video, I always like to just draw my lines in to remind myself what I'm multiplying together, okay? So here we have, the first thing we do is the two first terms. So x times x is x squared. Then we do the outside. X times 4 is 4x. Next is the inside. 2 times x is 2x. And last is the last terms in each bracket. 2 times 4 is 8. Okay, so that's the first step, is to distribute. The second step is to collect your like terms. So you can see we have two x terms here, so we're going to simply add those coefficients, which gives us that 6x. Okay, and you're going to do the same thing regardless of whether it's a positive or a negative sign. If you have negatives in there, you're just going to have to be a bit more careful that you remember that the sign is attached to the number. Okay, so this next one will be the same thing. X times x is x squared. X times 4 is 4x. Negative 2 times x is negative 2x. And negative 2 times 4 is negative 8. Again, after we've FOILed, we need to collect our like terms. We have 4x minus 2x, which gives us that final 2x. Okay, I'm looking at the third example now. We have x minus 2 times x minus 4. So again, you start with your first terms. X times x is x squared. Then your outside. X times negative 4 is negative 4x. Then the inside, negative 2 times x is negative 2x. And the last two terms, negative 2 times negative 4. That actually should be positive. Negative and a negative is a positive. Oops. So again, correct that on your sheet. Oh my gosh. Hang on. Zoom in so this doesn't look so bad. There we go. That's better. Okay, and the last one here, x minus 3 squared. So when we have a binomial and we see that it's to the power of 2, what that is saying is it's that bracket 2 times. So the first thing we have to do before we even start to FOIL or anything is to write that out twice, because that's going to make it a lot easier for us, right? We can't just simply square x and square negative 3. If we do that, we would not get the same answer. Okay, so you need to make sure that you're writing out that bracket twice. Once you've done that, you're simply using FOIL. Again, x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Okay, and then we just have one last step, remember, because we have to collect those like terms. And I can see that I have two x's there. So I'd have x squared. Negative 3 minus 3 is negative 6x plus 9. Okay, now that is fully simplified. All right. So, next example says, state an expression for the area of the shape given below. Okay, so remembering that area is length times width. So looking at this blue square here, it's telling us that our side lengths are x and x. Okay, that means it's a square. That means that all of these side lengths are the same. Okay, and in order to get our area, we simply have to do length times width. So we plug in our length as x, we plug in our width as x. X times x is simply x squared. Okay, don't get confused just because it's an x, right? It would be the same thing if you had like 2 times 2. You would just get a number instead of a variable. Okay, so now let's look at the pink one. It's a little bit more confusing. Obviously, your area of a rectangle and your area of a square are going to be the same. Okay, so your formula isn't changing, but you can see that the side lengths here are a bit different, right? With the square, we had just monomials, just one term. With these side lengths of our pink rectangle, we have binomials, right? We have 2 terms. Okay, don't get overwhelmed. You know how to do this. All you're going to do is you're going to plug in one side length for the length and the other for the width, just as we've done in the red here. So we have 3x minus 1 times 2x minus 3. Okay, you have to fully simplify this expression, so you need to FOIL. Okay, so we have 3x, remember first, 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. negative 1 times 2x is negative 2x, and negative 1 times negative 3 is 3. Again, don't stop there. Make sure you simplify those like terms. We can see we have 2 x's there, so we need to subtract the coefficient. So negative 9 minus 2 gives us that negative 11. Okay, so these formulas that we've created are simplified expressions for finding the area of these two triangles. Okay, so we can apply these skills to different sort of situations. So this is the first half. Give me a second to pull up the second one here. Oops. Okay, so let's look at a couple of special products. Specifically, there are two cases. Okay, so there are two special cases of binomial products which do not require the use of the distributive property or FOIL, which is the same thing, right? We just refer to it as one of the two to simplify. Okay, so there's two different situations. The first is when we're squaring a binomial. Okay, so if we were to expand and simplify in the way that we know how to do, it would look something like this, right? Like these examples we have here. Like I said, you would take that binomial, you would write it out twice, and then you would FOIL, and then you would collect your like terms. Okay, so in both of these two examples, this one and this one, that's what we've done. But there's a shortcut here. Okay, so as a general formula, if we have a binomial, so a plus b, and we have it squared, when you expand and simplify, you are always going to get this arrangement. So your a value is always going to be your first term squared. Okay, so in this first example, that would have been x squared, which we can see it is x squared. Okay, the second term is always going to be 2 times the first term times the second term. So 2 times a, which is 1, so 2 times 1 is 2, times the second term, which is negative 2, so that's 2 times negative 2, which gives you that negative 4. Okay, and lastly, your last term is going to be your second term squared. So it's going to be, in the first one, negative 2 squared, which gives you that 4. Okay? And this example will work the exact same way, right? So 16x squared is just 4x squared, right? Because 4 squared is 16, and x squared is x squared. 24x comes from 2 times 4, which would give us 8 times 3, right? So 8 times 3 is that 24x. And lastly, 3 squared is 9, okay? Personally, this seems like a lot to remember. You may want to just simply expand and simplify, okay? Because likely you aren't going to necessarily remember this formula here, okay? So the other time that we don't necessarily have to expand and simplify is when we have a difference of squares. So a difference of squares, all that means is that you're going to have two binomials where in one you're going to be adding a term and in the other you're going to be subtracting that same term. Okay, so notice how these two brackets look exactly the same except one is adding and one is subtracting. Same thing over here, right? We have 4x plus 2 and then we have 4x minus 2. So that's what we call a difference of squares. So again, you can absolutely just use your distributive property and expand and simplify these. You're still going to get the right answer. All this is showing you is little shortcuts. Okay, so if you expand and simplify the first one, you're going to end up with x squared minus 9. If you expand and simplify the second one, you're going to end up with 16x squared minus 4. And it shows you the process there. All they've done is FOILed and collected their like terms. Okay, but we've noticed something about these difference of squares. So generally, if we have a difference of squares, your like once you expand, you're always going to get the same thing. So your a value is always going to be your first term squared. Okay, so the first term in this first example was x. So my first term when I expanded is x squared. My first term on this one is 4x. If I square 4x, I end up with that 16x squared. Okay, it is always going to be minus. Okay, it's always going to be minus. And the reason for that is if you have a positive and a negative, it's always going to be, and you're multiplying, you're always going to get a negative number. Okay? And your last term is always going to be the second term squared. So for this first one, we had 3, right? 3 was our second term. 3 squared is indeed 9. Okay, in this one, our second term is 2. 2 squared is 4. Okay, so again, if you want to just expand and simplify these, I don't blame you at all. It's probably what I would do. But if you want kind of that little bit of a shortcut, then you are welcome to use these two general forms for that. Okay, just a quick couple examples here, focusing on that difference of squares and the squaring a binomial. Okay, so again, when we're squaring a binomial, the first term is just going to be the first term squared, so x becomes x squared. The second time was 2 times the first. Okay, so 2 times the first times the second term. So 2 times 1 times 4 gives us that 8x. And lastly, your last term is simply the second term squared. So 4 squared is 16. Okay, this one here, remember, this one you can actually see on my screen still. The first term is just the first term squared. X squared is x squared. And it's always minus, and then the second term is whatever the second term is, squared. 5 squared is 25. Okay, same thing with these ones here. 2x squared is 4x squared. 3 squared is 9, always has to be minus. Okay, and lastly for this one, first term is the first term squared, so 3x squared is 9x squared. Middle term is 2 times 3 times negative 7, which gives you that negative 42. And the last term is just negative 7 squared is 49. Okay, so again, the key here is just knowing how to expand and simplify using FOIL. This is kind of just some extra stuff that you can use to help you along the way. Okay, but this is the end of our first note of our third unit.